Hello everyone and welcome to the Math Bender. This is Trigonometry section 2. I'm going to discuss about cosine sketching and its dynamics. Let's start. Okay, so basically if I take out the values of cos of different degrees, so for example cos of 0, it's going to be 1. I can write that down. And you can take out all the values. So these values are going to be cos of 90 becomes 0, then negative 1, then 0 again, and 1. So if you draw the basic parent function of cosine, it's going to look like this, where 0, this point here is 90 degrees, this point here is 180, this is 270, and this is going to be 360 degrees. This is cos x. And similarly in radians, cos of 0 is 1, and pi over 2 when in radians is 0. All the same values, just that the unit of angle measurement is changing to radian. And the curve is going to look like this again, where this is 0, this is 2 pi, this is pi, this is pi over 2, and this is going to be 3 pi over 2. Cosine function is by default a many to one function. Its characteristics are such that the domain of the function is x belongs to real number, but in questions perspective, they give you the domain for which selective domain you will have to sketch the curve. The range by default is from negative 1 is less than equals to cos of x is less than equals to 1. Let's see some of the variations of cosine after looking at multiple waves. So this is one wave that completes its cycle at 2 pi. Note that in this section of the video I will only discuss about cosine in radian mode. Since I talked about sine in degree mode, so I'm going to be discussing with only in radian, so that you have a clear idea how every curve looks like in radian. The next wave after this is a repetition, another cycle starts. And if I change my color and draw them at the negative side as well, and the last one is going to be, so if I have to label them all, so this is 0, this here is pi over 2, this is pi, this here is 3 pi over 2, and that is 2 pi. The same way, if you keep on increasing, so this is going to be 4 pi, 3 pi, and if I just increase pi over 2 to 2, it gives you 5 over 2 pi, and this here is 7 over 2 pi. The same values are going to be the other side is negative pi over 2, negative pi, this is going to be negative 3 pi over 2, this is negative 2 pi, and so on, all the values. So these are 4 different waves. The period of this wave, which means the point where one cycle completes, is 0 till 2 pi. So 2 pi is the period of that wave. This is y is equals to cosine of x. The amplitude of the wave is 1. So let's see some of the variations of it. So if I have to draw the same cos of x for different domains, it will look like this. For 0 to 2 pi, it will be at one complete wave, where this value is 2 pi, this value is pi, this value is 3 pi over 2, and this value is pi over 2, and that is 0. The domain is for 0 to 2 pi. For this, the range will be from -1 till 1. For 3 pi over 2, as you could see, you just have to draw. So this much of the curve, that's it. So this section, this part is missing out because the domain restricts you to draw the curve from 0 to 3 pi over 2. This is pi and this is pi over 2. Now for this section, -pi till 3 pi over 2. So from 0 to 3 pi over 2, we already know that it's going to be like this until here. Now after that, it's going to be like this. So this here is minus pi over 2, 0. This is pi over 2. This is pi. This value here is 3 pi over 2. So 1 till -1. The same case, -pi over 2. So from 0 to pi over 2, the cos curve looks like this. And from 0 to -pi over 2 is going to be like this. So -pi over 2 till pi over 2. The range of this function is 0 is less than equals to, I just write f of x is less than equals to 1. The graph does not reach the -1 part. You may try drawing with different other variations of the domains and check for yourself as well. Alright, so let's look at some other variations. So f of 2x we already have established with the sine function that f of 2x is the shrinking of the graph, or in other words, is the stretching of the graph with a scale factor of 1 over 2. The point where 90-degree was existing before in cosine or sine curve, now after having an impact of f of 2x, it becomes cos of 2x, and that point is half. So in this scenario, which means within that 360 degrees or 2 pi radian, the cosine will have by default, which is having a period of 360 or 2 pi, is now going to have two waves in that domain. And if I just extend this and I mark these values, so this is going to be 2 pi now. So half of it is going to be pi and 0. So as I explained in my previous video as well, so let's, if you are having a trouble writing these values down, so just break them into multiple sections. So 1, 2, 3, 4, 5, 6, 7, 8. So 2 pi divided by 8 values. So one value is going to be pi over 4. So this is pi over 4. This is pi over 2. Sorry, pi over 4. That is pi over 2. This is 3 pi over 4. This is 5 pi over 4. 6 pi over 4, or 7 pi over 4, and so on. The period of this wave is only pi radian because one wave completes in pi radian. Same goes for f of 3x, so which means the point where there was supposed to be only one wave is going to be now 3 waves completing in that region. So it's going to be 3 waves here, where this represents 2 pi, half of it is somewhere here, but I'll stick to the principle that we started taking. This is going to be one value, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I'm dividing 2 pi by 12 now to get a clear idea how it is going to be. So each value is going to be pi over 6. So this is pi over 6, this is 0. So this is 2 pi over 6 or pi over 3. This is 3 pi over 6 or pi over 2. This is 4 pi over 6 or 2 pi over 3. This is 5 pi over 6. I can write down as it is. This is 6 pi over 6, which is pi. 7 pi over 6. 8 pi over 6, which is 4 pi over 3. 9 pi over 6, this value here is going to be 3 pi over 2, 10 pi over 6, which is going to be 5 pi over 3, and this one is 11 pi over 6, and the last one is 12 pi over 6, which is equals to 2 pi. Although the question does not demand this much of a description, but I'm just trying to give you a clear idea how it is. So for period of this wave, we know that one wave by default has a period of 2 pi, and since divided by this number, you just divide that by this number, which means in that 2 pi there are 3 waves, so one wave is going to complete in 2 pi over 3. So this is going to be the period, and as you could see here, from here till here, one wave was completed in 2 pi over 3, just to give you an idea. So for half pi, which means in 360 degree, there's just half wave complete. This is probably the easiest. So this is going to be 2 pi, half of it is going to be pi. That's all. The range is -1 till 1, and the period, as we already agreed upon, that which means 2 pi divided by 1 over 2, which is going to be 2 pi times with 2, which gives you 4 pi. So one wave, half wave, if it is completing in 2 pi, then one complete wave is going to be completing in 4 pi radian. So 3 pi over 2x, so which means there are 1.5 or 3 over 2 waves. So cos of 3 over 2x. So 3 over 2 means, first of all, draw them. So 1 and a half. So this here, this value here is 2 pi, and 1, 2, 3, 4, 5, 6. So 2 pi over 6 is the value. So which is going to be, if I divide 2 pi over 6, the first value represents pi over 3. This is 2 pi over 3. This is 3 pi over 3, or pi. This is going to be 4 pi over 3. This is going to be 5 pi over 3. And last one is going to be 2 pi. The range is going to be from -1, as same as sine, to 1. One more thing. If I ask you for the period of this wave, and it's going to be 3 over 2, it's going to be 2 pi divided by 3 over 2, which gives you 2 pi times with 2 over 3, or is equals to 4 pi over 3. This is the period of one wave. Now here, so in operations on cosine function, which means that if negative, this means negative cos of x, we already established that it's going to be a reflection in x-axis. So by default, a cosine wave looks like this. And this wave is a reflection on the mirror line, this line, and it will look like this. So if this is cos of x, this is going to be negative cos of x. So absolute value of f of x means negative curve. So cos of x, writing down in the absolute, and the curve converts all the negative of function. So negative function reflects only on the line x-axis. So if by default this is the curve here, the curve will look like this now. So this part and this part remains the same, they were both positive, so only this part is going to be reflecting, and it's going to be, in this case, this. It looks like this. and where this is 1, this is 0, and all the values remain the same. So it's a reflection, and the range of this function will be, range will be from 0 is less than equals to modulus of cos of x is less than equals to 1. F square x is, since there's a square function added to it, which means all the negative values turn positive and squared the amplitude. But in this basic parent function, the curve which looks like this, so this is negative 1 and this is 1, so negative 1 squared makes it positive 1. The curve will look like exactly again the same. So this is how it's going to look, and this is cos squared x. So when I apply cos squared x, this is what it means. Now this one, and the most important one, I believe, so this is cos of negative x. We already agreed upon that negative x, f of negative x, represents reflection in the line y-axis, in y-axis. So the curve which originally looks like this is gonna now reflects on the y-axis and looks like this. If I draw the original curve with this blue ink, now as you could see that the blue curve here, which I'm mentally thinking to draw that as cos x, and this one as cos of negative x, and if you see both of them actually after 0 point, this is continued and looks as same as the other one, because if I extend cos x graph, it looks like this in the negative region. So which means that cos x, cos of negative x, is exactly same as cos of x, hence concluding to our identity that cos of cos of negative x is equals to cos of x. So this is more or less about cos of x. I'll discuss more about tan function in my next, and then we'll discuss about past paper related questions. Until then, take care. Bye.